And welcome back. As we continue looking at exceptions today, we're specifically going to help address the question of when should we actually use exceptions. So exceptions so far have been kind of in a simplistic lens. All right, we've done a lot of things, for example, like division by zero, which is of course something that we can handle in other ways that don't require us to write an exception class. A better guideline for how we can use exceptions is to separate throwing an exception and catching the exception into separate methods. In most cases, you should include any throw statement with a method definition, list the exception class in a throws clause for that method, and place the try-catch blocks in a different method. So let's go outline the process just a little bit here. In outline form, the technique would be as follows. Public void, your method, throws, your exception, throw, new, your exception, and then maybe have some kind of argument that you put into there. Then when your method is used by some other method, the other method must account for that exception. Public void, other method, try, your method, catch, your exception, and then handle that exception. So the thing you'll notice is that we're avoiding throws. Even this kind of use of a throw statement that we have seen is typically reserved for cases where the throw statement would be unavoidable. If you can easily handle a program in some other way instead of using the throws, do not use an exception. Reserve throw statements instead for situations in which the way the exceptional condition is handled depending on how and where that method is used. If the way that the exceptional condition is handled depends on the how and where of where that method has been invoked, then the best thing to do is let the programmer who invokes that method handle the exception. In all other situations, though, it's preferable to avoid throwing the exception to start. So let's outline a simple scenario in this kind of situation. So let's look at this through a hospital lens, all right? So let's say we're writing a library of methods to deal with patient monitoring systems for hospitals. Healthcare is a very real thing that, programming gets its tangles in. And one method that you might have to do is to compute the patient's average daily temperature by accessing the patient's record in a file and then dividing the sum of temperatures by the number of times the temperature was taken. So a very real world application. Now suppose these methods are used for creating different systems to be used in different situations. This is going to cause our scenario to have a couple different branches. So what, for example, should happen if the patient's temperature was never taken? And so the averaging would involve technically a division by zero because you have 0 cases. In an intensive care unit, this would indicate something's obviously very wrong for the system. The potential division by zero would occur. An emergency message should be sent out. However, for a system that has a less urgent setting, such as outpatient care or even non-critical wounds, it might not have any significance, so a simple note in the patient's record would suffice. In this scenario, also note that the method for doing the averaging of the temperature should throw an exception when this division by zero occurs. List the exception in the throws clause and let each system handle the exception case in the way that is appropriate to that system. So this is, of course, when a exception class is very applicable. Yes, we're doing division by zero, but the scenario itself is more dictating what we need to use. All right, and that, of course, is this question that we keep coming back to. When to throw an exception. Exceptions should be reserved for situations where a method has an exceptional case, and individual invocation of the method would handle the exceptional case differently. In this situation we looked at, you could throw an exception in the method definition, not catch the exception in that method, but you can list it in the throws clause for that method. This way, the programs who invoke the method can handle the exception differently in different situations. So let's look at this through an example. Let's say we want to retrieve a high score. Throwing an exception in a method is especially helpful when the exception has no relationship to the return value of the method. For example, consider a method that would return a high score for a game. What should that method return if the high score, for example, has never been set? Well, we obviously would want to first think about this. How did this function if we did have a score, right? We want to retrieve a high score. Well, one strategy that you can employ is you can say, you know what, we're going to return a special value such as a negative number. If there's no scores entered, we're going to say it's a negative number because normally scores are going to be probably 0 or higher. So the program would output then -1 when the high score has not been set. In this case, the return value is treated like a normal high score, but it's really an exceptional condition. Now, of course, we could do things like add a check for a negative number, but what if a negative high score is valid in this case? Well, what's if it could be you can have negative scores? So we have no way to tell if the return value means that the score was never set or if this is an actual high score. So therefore, a better solution is to throw an exception if that high score is never set. The code in the main method can check for the exception and handle it separately from the return value. And this is leading into a topic known as event-driven programming. Exception handling is kind of our first example of a programming methodology known as event-driven programming. With event-driven programming, objects are defined so they send events, which of course are themselves are the objects, to other objects that handle those events. Sending the event is called firing the event. You think about it as the way we've kind of handled code, it's the execution of it. In exception handling, the event objects are exception objects. They are fired or thrown by an object when the object invokes a method that throws that exception. An exception event is then set to a catch block where it's handled. And of course, a catch block is not exactly an object, but it has kind of the same idea as what we're going for here. Now, our programs up to this point, including with our exception handling, are more of a mixed event-driven programming through our exception handles with some traditional programming techniques. And last, let's go ahead and take a look at that high score class to kind of get some examples here. So in here, of course, I have my high score class. This is just that default one that we had talked about. So if I go ahead and run this program, you see we get -1 and 100, which of course, -1 could be a very valid number for us to use. However, the thing that we can run into here is, what if this is indeed a valid score? Well, that's again where we come back to that saying like, hey, instead of saying that it's -1, because you can see here we get score. If the score is not set, we return -1. We can instead create an exception class that will then throw the message that score is not set, and that is then invoked by that method. So you can see in here we get score is throwing score not set, and of course that would throw that exception right here. So when we throw the exception version of this class, we instead get the message score not set, and then we get 100. And you notice it doesn't terminate the program for it to do that, because even though it's caught by that exception here of score not set, it allows that program to keep execution. So just because something hits a try catch block does not mean it's the end of the program, even when you are caught, because notice it's not a termination here. So again, just keep in mind that the context of what you're trying to use for your exceptions is going to be what really kind of drives whether or not you should be implementing it within your program.